Hello everyone, welcome back to my channel NCERT Maths with Bardeep. Today we are going to start a new chapter of your grade 10, that is chapter number 3, pair of linear equations in two variables. So you have already done linear equation in one variable in grade 8 and linear equation in two variables in grade 9 also. Let's have a quick recap. So first of all, linear means whose degree is 1. Okay, so this example, that is 3x plus 5 equals to 9. So since the degree of x is 1, so this is a linear equation. Then we will see how many variables. So in this equation we have only one variable x. So this is a linear equation in one variable. Let's take another example. This is 3x plus 4y equals to 5. So now we can see we have two different variables, that is x and y. Then we will check the power or the degree of both variables. So here x has power 1, y has power 1. So means both variables has power 1. So this will be a linear equation in two variables. I hope the difference is clear. In one variable, first of all, in both the cases, whether this is linear equation in one variable or the linear equation in two variables, the degree will be 1. Means the degree of the variable involved in the equation will always be 1. Secondly, if it is a linear equation in one variable, only one variable is there in your equation. As the name suggests, if it is two variables, then there will be two separate variables in our equation. But in this chapter, we will consider linear equation in two variables, but they will be in pairs. Okay, that means we will solve two different linear equations in two variables. Okay, so before going into detail, let's revise what is the general format of any linear equation in two variables. This is ax plus by plus c equals to 0, where a, b and c are any real numbers, but make sure that a and b both should not be 0. Okay, so in a generalized way, when we need to specify this condition that a and b are not both zeros, we will represent this by square root of a square plus b square should not be equal to 0. Okay, so the general format is ax plus by plus c equals to 0, but make sure that square root of a square plus b square should not be 0. Next is what is solution of an equation. As you already know what is the solution of any equation, means what value we should put in our equation that left hand side is equal to right hand side. So solution of an equation is the pair of values, one for x and other for y, which makes the two sides of the equation equal, is called solution of an equation. Because now in this chapter we are considering linear equation in two variables, so we need one value of x, one value of y, that we put together in our equation, and left hand side is equal to right hand side. Let's take an example. 2x plus 3y equals to 5. Let's put x as 1 and y as 1. So what will be left hand side then? 2 into 1 plus 3 into 1. Okay, so this is 2 plus 3 equals to 5. And what is right hand side in this case? That is also 5. So left hand side is equal to right hand side. So this pair, that is x as 1 and y as 1, is a solution of this equation. So we can say therefore 1 comma 1 is a solution of this equation. See here what I have written is, I have written in this a pair form. Okay, so as you already know, this is similar to the coordinates of a point. So first value will always be of the x and second value will be of y, or you can write x equals to 1 and y equals to 1 is a solution of this equation. So let's try another one. So x as 1 and y as 2. So put x as 1 and y as 2. So 2 plus 6 is 8 and right hand side is 5. So here left hand side is not equal to right hand side. Okay, so we can say that x as 1 and y as 2 is not a solution of this equation. So overall we can say that each solution that is represented as x comma y means value of x and value of y of a linear equation in two variables of the generalized form ax plus by plus c equals to 0 corresponds to a point on the line representing the equation and vice versa. So you have covered in your grade 9 also what is the graph of any linear equation in two variables. It is always a straight line. Then what is the solution of that equation? Means that value of x and y which when we put in our equation, so left hand side is equals to right hand side. So whatever is the solution of your equation, that point will definitely lie on the graph of that equation. Clear? Means any solution, suppose I am taking this line somewhere like this. So we can say that if any solution is there, that solution will always lie on the line, on the graph of the line. On the other hand, if line is given to us, we can take any point which lies on that line. That point will be a solution of your equation. So now let's see the next topic. So in your grade 9th also you have studied that geometrical representation of a linear equation in two variables is always a straight line. That is, whenever you draw a graph of your linear equation involving two variables, the graph is always a straight line. So now in this chapter we are considering pair of linear equations, that means two equations at a time. So three different possibilities are possible, that any two straight lines can be categorized into these three types. First one is two lines will be intersecting, second is lines will be parallel, and third is coincident lines. Let me explain. So if the graph intersects at exactly one point, this pair of lines is referred as intersecting lines. That is first condition. Okay. Second is the graph of these two lines may be parallel. So this way. That means they will never intersect at any point. Okay. And third is coincident line. Coincident line means if we draw graph of one equation, we will get this, and the second graph or the second straight line will merge on that. So same points we will get for second equation also. So these type are coincident line, these are parallel lines, and these are intersecting lines. So what I said is the graph of one linear equation in two variables is a straight line. But our topic is pair of linear equations. That means we are considering two equations at a time. So definitely both will represent a straight line. So now we will have two different straight lines. So two different straight lines can be of any category. Number one is intersecting lines if they intersect at exactly one point. Second is they are parallel to each other. That is, they will never meet or never intersect. And the third category is both lines coincide. That means they will merge into each other. That type is coincident lines. Okay. So these three lines will have three different type of solutions that we will discuss in our next topic. So in this chapter, we will study two different representations of linear equation in two variables, that is geometrical representation or graphical representation, and second is algebraic representation. So in both ways, we will study that we can find the solution of the given pair of linear equations. So now let's focus on geometrical representation. So let's understand the graphical representation or geometrical representation of the pair of linear equation in two variables. Suppose I am taking these two equations, that is x plus 2y equals to 6 and 2x plus 3y equals to 5. So first of all, we should make a table in which we will put different values of x and y for each equation, and then take any 3 points and plot your straight line for that particular equation. So we will make two different tables, one for each equation, and then we will plot them on the graph. Okay, so let's see first of all how to fill this table. This is already covered in your previous grades. So let's put the value of x as 0 and find the corresponding value of y. So put x as 0. Let's see, this is the first equation, this one. This is x plus 0, okay, x means 0 plus 2 into y equals to 6. So 2y equals to 6. And what is the value of y then? 6 by 2 as 3. So the point is 0, 3. Okay. So let's take another value. So here see, this is even, this is even. So always prefer to put values in even number in this case, so that you will get the exact points rather than in decimals. So here it is, let's suppose that x is 2, then put in this equation. So this is 2 plus 2y equals to 6. Okay. So 2y is equal to 6 minus 2 is 4 and y is 2. Okay. So for x as 2, y is also 2. So now let's put some another value, that is x as 12. So 12 plus 2y equals to 6. This 12 will be shifted to other side and we will get 2y as 6 minus 12, that is minus 6. Then what will be y? Minus 6 by 2 as minus 3. So y will be minus 3. Okay. So now these 3 points are for this equation. Let's plot them there. So this is, first point is 0, 3. So 0, 3. This is our first point. Okay. Second is 2, 2. So 2 and 2, this thing. And third is 12 for minus 3. So this is 12. At 12 I need minus 3. So somewhere here. Okay, so let's join them. I may not get exactly straight line. So this will be the straight line for this equation. So we can write the equation here, that is, always make sure that you should write it in the same position. Okay, so this is our straight line for this equation. Now let's make a table for this. So again we will start with x as 0. So now put x is equals to 0 in second equation. So 2 into 0, that is 0, plus 3y equals to 15. So from here y is 15 by 3, that is 5. So our first point is 0 and 5. So again we can notice here that this is 3 and 15. So something multiples of 3. So let's put that x as 3. So you can randomly put different values and find those values which are without decimal. So let's try 3 here. So 2 into 3 plus 3y equals to 15. This implies 2 into 3 is 6. So it will go to other side. 15 minus 6 is 9. So y I will get as 3. So second point is 3 and 3. Let's put this again, same value, x equals to 12. So this is 2 into 12 plus 3y equals to 50. So 3y equals to 15. 2 into 12 is 24. So it will be 24. So we will get minus 9. So then what is y? Minus 9 by 3, minus 3. Okay. So this is the table for second equation. From table itself you can notice that this and this is a common point in both equations. So that will be the solution of your equation. But sometimes it may happen that you won't be able to get same point in your table. So we will make the graph and then produce them further or extend them further and see where they will intersect. The intersection point of those two lines will be the solution of your pair of linear equations. So let's first plot this. This is first point is 0, 5. So this point is 0, 5. Next is 3, 3. So see, in between 2 and 4 I will have 3. So I will extend it further. So somewhere here. And third is 12 and minus 3. So this point again. This thing. Okay, so something like this. Okay, so this equation is 2x plus 3y equals to 15. When you will plot this thing with your scale, you will get straight lines. So these two lines will definitely intersect at one point if they have only one solution. So this is how we will plot the graph, and this is our geometrical representation of the pair of linear equations in two variables. So on the basis of graphical representation of a pair of linear equation in two variables, there are three different possibilities. The first one is as shown here, that is the both lines are intersecting lines. Intersecting lines means that we have only one unique solution. Okay, if the lines are having one solution, they are referred as consistent pair of equations. Second possibility is these graph or these lines are parallel to each other. Parallel to each other means they will not meet anywhere. So no intersection point means that pair of linear equations will have no solution. So no solution will be referred as those lines as inconsistent. Okay. And third possibility is we will get coincident lines. Coincident line means each point will be same for both equations. So we will have infinitely many solutions. Okay. Whether we have one solution or infinite many solutions, we will refer those pair of equations as consistent pair of equation, and if they have no solution, we will refer it to as inconsistent. Okay, so this is all about this video. See you in my next video with the next topic of this chapter. Thank you.